This video is on applications of quadratics. It is similar but not the same as one or two of your homework problems. There's other homework problems, like one about a rocket launching and figuring out when the rocket is at a certain height, that you really need to think about what the quadratic equation is telling you, like what it means, what the various parts stand for. If you have questions, always feel free to message me. Let's jump into this problem now. The dimensions of an old door are 4 feet 0 inches wide by 6 feet 6 inches high. If this door is enlarged by gluing a border of equal width on all 4 sides, the area is increased by 8.0 square feet. What is the width of the border? Let's start by drawing a picture. We have our original door that's 4 feet by 6.5 feet because, of course, 6 inches translates to half of a foot, not 0.6 feet. And then we have the width that is the same on all dimensions. So left and right, we glue on X number of feet, and top and bottom, we glue on X number of feet. What we cannot do for this is we cannot just say, oh, there's X by X is this increased feet. We can't say X squared equals 8 because area is nonlinear. What we're going to do instead is we're going to think about how this area has changed. So I'm going to think about this as one large rectangle. To do that, first I'm going to think about the original area of the door, pictured here in white. So the original area is 4 feet by 6.5 feet, which works out to be 26 square feet. The new area is going to be increased from this. So the new area I know is an increase of 8 square feet. So that means the new area is 26 plus 8 square feet, which works out to be 34 square feet. Now let's write a mathematical expression representing the area of this enlarged door. So my width originally was 4 feet, but now we have X feet and X feet glued on either side. So the width is now 2X plus 4. The height, similarly, was 6.5 feet, but we've glued on 2X lengths. So the new height is 2X plus 6.5. There's our expression. And this expression is equal to the new combined area of 34 square feet. To write this a little differently and have our x's first, we could write this as 2x plus 6.5 times 2x plus 4 equals 34. Let's go ahead and solve this. For solving this, the first thing I'm going to do is distribute through to get rid of the parentheses. So 2x gets distributed to both of those terms, 6.5 gets distributed to both of those terms, and multiplied out, this becomes 4x squared plus 8x plus 13x plus 26 equals 34. If we move that into standard form, what we're going to do is we're going to move everything to one side and combine like terms. So I'm going to subtract 34 on both sides and combine like terms, and we end up with 4x squared plus 21x minus 8 equals 0. There is a quadratic we can solve. To solve this, we could try and factor, but I can tell you right now that's not going to turn out well. Instead, let's apply the quadratic formula. To apply the quadratic formula, we first want to identify the coefficients. So the coefficients here are 4, 21, and -8. Now we can put that into the quadratic formula. The quadratic formula, of course, is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. I recommend just writing that down every single time you use it. So with these values plugged in, since b is 21, we have x equals -21 plus or minus the square root of 21 squared minus 4 times -8, so there's our 4ac, divided by 2 times a, or 2 times 4. Performing some of the computations underneath the square root, that simplifies to 569, and then divide by 8. I encourage you to pause the video and actually work those calculations out on your own. I see a lot of silly arithmetic errors on working these problems. It's good to get the practice. To further simplify that, what I did was I took my calculator and I entered in parentheses -21 plus the square root of 569, closed the parentheses, and divided by 8. Then I did the same thing, except I subtracted the two numbers in the numerator. Those are what I came up with. X equals 0. Well, you can read them. So about 0.36 and about -5.6. But let's think about the context of this problem. What did the x stand for? Does a negative number make sense in this context? Well, x stood for the width of the border that we glued onto this door. So no, a negative number does not make sense in this context. We can throw that negative answer away. So our final answer is this first one. We want to think about significant figures in appropriate rounding. The best rounding might be to change this back to inches and round from there. This works out to be approximately 4 inches. But even rounding to the nearest tenth of a foot, which would also be appropriate since we're given an area increase of 8.0 feet, we would end up with that the border is approximately 0.0 feet in width. Thank you.